Hi, I'm Rob Futrick, Principal Program Manager Lead for Azure's HPC Software and Services Platform, and I'm here today to talk about our software platform and a bit about CycleCloud. So, Azure's HPC platform is built by HPC people for the cloud. And so it is purpose-built with HPC workloads and constraints in mind. We understand that these are some of the most challenging workloads that our users have, and so we're building the capabilities for them to address those challenges in Azure. We also want to add a lot of Azure's additional capabilities to those workloads. The latest ML technologies and other offerings give you true intelligence on top of traditional HPC simulation approaches. But that also includes the rest of Azure and the rest of our offerings, whether it's storage, other types of SKUs, or other technologies, which make our HPC platform incredibly versatile. And of course, Microsoft has been operating for decades around the world and is one of the most trusted computing companies in the world, and that extends to the HPC platform. So what's the philosophy behind what we're building? And it's basically we look at why our customers want to run in the cloud to begin with. And so over the years, kind of the 3 or 4 things we've noticed is they want agility and speed. They want to be able to move quickly when they have sudden changes to their business, sudden changes in demand, access to new technologies faster than traditional procurement cycles would have allowed. They also want to run at greater scale than they ever even thought possible. So to be able to take their workloads and drive them bigger and bigger based on their business needs and their opportunities as opposed to the fixed size environment they had. And finally, sometimes people don't want to run infrastructure anymore. That's not their business. They want to trust somebody who knows how to do it. Well, if the cloud is so amazing for all those, why haven't people traditionally migrated their HPC workloads to the cloud? Well, historically speaking, the cost performance wasn't there. It made cloud useful for burst and sudden needs, but kind of the traditional steady state wasn't necessarily economical. Data control access, especially in a hybrid world, and how to manage that was very complex and challenging. And finally, just the governance complexity, the technical complexity, and the overall challenge of taking these optimized and tuned environments and adding in cloud capabilities made it very difficult. And so the philosophy behind our HPC software platform is to enable those benefits by addressing those shortcomings. And so if you want to know where our HPC software platform is, and actually to the greater HPC platform in general, and where it's headed, just keep those goals in mind. So what have we built? Basically, we built an entire stack of HPC resources. Starts off at the ground level where you'd expect at the compute series. So we have our H series, CPU compute, our N series, which is accelerators and GPUs, and even offerings like traditional Cray supercomputers. So everything from a single optimized VM up through massive traditional HPC capabilities. We've married that to HPC storage options, whether it's a scale-out NFS cache, or a NetApp NAS offering, or something like a parallel file system in Cray's cluster store. We've added in best-in-class networking, and that is both to Azure, so from your location to Azure's data centers through ExpressRoute, or within the Azure data center itself using the fastest InfiniBand networking available. Now, once we've offered you this storage, this compute, this networking, we've then built higher level services to orchestrate your workloads and reduce that technical complexity, addressing that challenge I mentioned earlier head on, and make it so that running your workloads in Azure or in a hybrid function is as simple or even simpler than running on premises. And then finally, to the intelligence we want to add on, we've built transformative services on top of that, such as Azure Machine Learning, Azure Data Lake, Azure ML Compute, to allow you to drive new innovations and new value. So overall, whether you're using the software platform or just the raw hardware in Azure, or honestly any part of Azure's HPC platform, we differentiate through several capabilities. And one of them is scale. As I mentioned earlier, customers want to be able to run at a bigger scale and at larger machine count, core count, storage size than they ever thought possible in a fixed on-premises environment. And also cost. We understand that we have to address that cost performance issue, and we've done that, whether you're using workload optimized VMs that give you kind of a tailored solution, or whether you're using something like Spot VMs in order to drop the price significantly. We've also added in HPC Optimized Infrastructure, which gives you the performance and scalability that you need. That combined with InfiniBand networking means you can scale out your HPC workloads from single VMs all the way to hundreds of VMs, tens of thousands of cores in a single tightly coupled job. And you can run multiple of those at the same time, which means your whole environment can be in the hundreds of thousands of cores. And finally, you have a choice of any VM you want operating system. Do you want to run containerized workloads? You can. Windows, Linux, you name it, you can find it and run it in Azure. So, as I mentioned earlier, you have these tremendous capabilities. How do you actually take advantage of them easily and simply? We have two primary offerings, Azure Batch and Azure CycleCloud. Azure Batch is cloud-native job scheduling. It's basically HPC as a service. All the resources lie in Azure, and it's job scheduling kind of built from the ground up for the cloud. Azure CycleCloud is a complementary offering, which is really aimed at line of business IT people that run these HPC clusters, and it gives you a way of creating and operating traditional HPC clusters in Azure or in a hybrid function. Batch, in particular, is two main focuses. Orchestration. The VMs are coming and going. You want to optimize your use of Azure for your needs, and so the first part is batch pools, and that's what takes care of getting you the infrastructure when you need it. And a core differentiator for a cloud-native scheduler like Batch is that the idea that the infrastructure is coming and going is native and kind of first class to the scheduler. And along with it, being a scheduler is job scheduling. I think everybody here is familiar with that, but give it your tasks, it executes them, and gets you the results back. So Batch offers a bunch of other ways, whether it's application management, auto-scaling your environments up and down, monitoring them the entire time, detecting errors, both at the Azure level or the user level. And then finally, Azure Batch is also a SaaS enablement platform. It's for and by developers. And so it provides bindings for multiple languages and common frameworks. Then you have the complementary offering in CycleCloud. CycleCloud is almost like a traditional HPC cluster tool built for Azure. And so, as I mentioned earlier, users want to have access to scale and agility, and they want to trust Azure to run their infrastructure. But if we are telling their extremely talented engineers and HPC admins and whatnot to take these environments that they have tuned and perfected, and then we basically introduce all that cloud complexity on top of it, that's kind of a non-starter. And so the idea behind CycleCloud is to address that third challenge, the technical and governance complexity. And so it gives you instant access to Azure resources. It gives you support for any IaaS component that Azure offers. It will add auto-scaling and orchestration to third-party schedulers. Azure CycleCloud, unlike Batch, is not a scheduler, but you can bring the scheduler you're already using to Azure. It also adds some cost reporting and controls as part of that governance capabilities. And it supports hybrid workflows. And the big thing here is that we are announcing CycleCloud 8, which will be released shortly. And in CycleCloud 8, it has native support for Slurm's job accounting functionalities, which gives you the ability to take advantage of Slurm's own job accounting to enforce usage limits and to get a better understanding of who is doing what where. We're also updating CycleCloud's integration with OpenPBS to version 20, as well as support for CentOS 8 and Ubuntu 20. In particular, the security and performance improvements in those operating systems will make a big improvement to HPC environments. And finally, there's a major overhaul of the auto-scaling and orchestration integrations with the Grid Engine, whether it's the open source or the Univa versions of Grid Engine, and OpenPBS. And this has actually a lot of really exciting things. You'll get a much bigger scale improvement there. You'll get support for hybrid environments where you want to run your native on-prem Grid Engine or PBS cluster and then add in Azure resources kind of automatically. You'll get an auto-scaling CLI, which will give you capabilities like a dry run command. So you can understand what would have been provisioned in Azure had you actually submitted the work, to give you an idea of how to test out different workloads and what they might then do. And finally, we hope you don't need it, but if you did want to change the auto-scale behavior, you'll be able to customize it. So with that being said, switch over and show just how easy it is to run an environment in CycleCloud. The easiest way to get Azure CycleCloud up and running is to go to the Azure Marketplace in the portal, search for CycleCloud, and create one through the Azure Marketplace. You simply fill in a few details for the kind of VM that you want to run CycleCloud on and where in the world. You can review and create it, and you're off and running. Azure will provision the virtual machine, and it will install CycleCloud for you. Once it's installed, you'll have your cluster orchestration tool ready to go. You can simply log into the application and let's create a cluster. So if I'm a new admin, maybe I have a new researcher has joined the team and they want to run some particular simulations. In this particular case, they come to me and say, hey, I need a new Slurm cluster. Here's my application, et cetera. Can you get me set up? So I come down here, I say, yes, I want a new cluster. I would like that to be a Slurm cluster. We'll call it, Slurm workload. I have a few required settings. So where in the world am I going to be running this cluster? So for now, we can pick the West US region. What type of VM in Azure do I want to use for my job queue? We'll stick with the standard there. What do I want to use for my HPC VM types? Now, this is the VMs that Slurm will use to run a tightly coupled job or kind of a traditional MPI job. And so I can come over here and I can pick the high performance compute optimized SKUs, and I could pick the HC44s, the Intel-based compute optimized HPC SKUs. Now, all of our H SKUs and N SKUs are InfiniBand connected, as I mentioned earlier. So they are perfect for these HPC workloads. The HTC VM type is really for the throughput workloads. These are the embarrassingly parallel or otherwise not InfiniBand requiring workloads. Maybe something like risk modeling or sequencing alignment in genomics, you name it. And so for them, we can keep the Fs. So this particular user, let's call her Michelle, she might say, okay, well, I'm going to be running simulations of maybe 400 cores, and I'll need several of them at the same time. So maybe we'll give her 2,000 cores in the HPC cluster. But maybe every once in a while, she wants to run a very large throughput simulation, and so we'll want to make sure she can run that up to 10,000 cores. And then because of the types of workload that she has, we can actually use Azure Spot Vms, and we'll just let them set the price. So we'll come down here and pick the subnet. And then if we needed to attach storage, we would have the options to attach NAS storage or some other kind of file server. We could even configure that maybe the specific type of Slurm version, whether we actually want to use the job accounting. We could install additional kinds of software and basically make this cluster exactly what that researcher, that quant, that engineer needs. In this particular case, we're good to go. So we save the cluster. You'll notice here that it's telling me I haven't used anything yet, and so there's $0 spent. If I needed to configure access for this researcher, I could simply share this cluster with them. But for this, we're going to say go. So that's it. CycleCloud is going to go out to Azure. It's going to provision that node. It's going to create the other VMs, or at least get them ready to be created when the user submits their workloads. They're off and running. In the interest of time, we'll jump over to a previously created cluster, slightly different settings, and we'll show how easy it is to submit a job. So first thing I'm going to do is log into Cloud Shell. This is part of that enterprise security we talked about earlier. And from here, I can access my CycleCloud environment because I've already provided it an SSH key for my user. And so I and only I with that key can connect. So the first thing I'm going to do here is connect to my CycleCloud instance. So now I'm actually on that CycleCloud box. You'll notice the demo CycleCloud that I have spun up. And from there, I'm going to connect to the job queue in that Slurm cluster. And so this is exactly how that researcher may log in and submit their jobs. And so from here, I can run a command to submit a job. Now, what this is going to do is this is going to submit a single command. In this case, it's just printing out the host name, which isn't impressive, but it's telling Slurm that this is a tightly coupled job. It needs to run across 14 of the HPC VMs that I've spun up. And so I submit the job. You can see that it's now submitted job number 6. I'll come back here to CycleCloud, and you can see almost immediately CycleCloud picked up on the fact that it needs to acquire 14 virtual machines. It will spin them up. That job will execute. It'll probably wait a few seconds to see if I've submitted anything else, and it'll turn them off. But in the meantime, I may decide that, hey, I want to submit a second simulation. And so this one only needs 6 VMs. Submit this. We'll come back. CycleCloud's already detected that I submitted another job. Now it's acquiring 20. But let's say I typo this and I type 66 instead of 6. Because I set that cluster limit, CycleCloud will not try to orchestrate more VMs, and it won't even take up the remaining. And so I know that my user is safe within their guardrails. They're going to stay within their budget, but they have the power and flexibility to get what they need done for their project. And that is how easy it is to create a new HPC environment using CycleCloud and get your users up and running. But there's plenty more capabilities that Azure offers, whether the HPC platform or the additional capabilities we talked about earlier. And so you can go online and find some more information at our website, whether it's at azure.microsoft.com/solutions/high-performance computing. You can also explore Azure solutions by industry, whether it's energy or public sector or health and life sciences or financial services and others. And finally, you can engage a partner around the world to help you implement your high-performance solutions and assist you in your HPC journey. Thank you.